ionization energy of hydrogen-like ions or atoms. So the energy of the nth energy state En equal to minus 13.6 Z square upon N square, so much electron volt. So the ionization energy energy is equal to 0 minus 13.6 Z square upon N square electron volt. So this is equal to 13.6 Z square upon N square electron volt. This is not so much. Now we take the example. Let you take this lithium 37, simplest atom. Here this Z is equal to 3. So the electron distribution is like 2 and 1. This is now first energy state, this is now second energy state. So here the N, this is equal to 1, this is now equal to 2. The second energy state is here. So this N is equal to 2 here, Z equal to 3 here. So now what we have, that ionization energy of lithium 37 atom. Now this is equal to 13.6 into Z is equal to 3, so this is now your 3 square upon N square. So much electron volt. So this will be your 9. It is equal to 13.6 into 9 upon N square electron volt. So this will be equal to 9 6 is 54. So this is now 4 and 5, 27, 32. So this is now 2, this is now your 12.4 upon N square electron volt. So now what we have, that the last electron, this last electron is found in N equal to 2. The last one electron is in N equal to 2 energy state. So the binding energy, so ionization energy of lithium 37, this will be equal to how much? 122.4 upon 2 square. So much electron volt. So this is now your 4. So 4, this is now 3, 0.6. So much electron volt. This is so much ionization energy of the lithium atom. And now if this one electron, last one electron that was in the second energy state, if it is found in the third energy state, then we will put N equal to 3. If this is found in fourth energy state, then we will write down the 4. So that will be the second binding energy, third binding energy, and so on. If last electron one electron in lithium 37 hydrogen atom is found in n equal to 3, 4, 5, etc. energy states. Then binding energies will be second, third, fourth, binding energy. Respectively. So now if we have to find the second binding energy, second ionization energy. Ionization energy. This is now ionization. I means ionization. So second ionization energy, this will be your how much? Now this is 1 to 2.4 upon. Now you put n equal to 3. So this is now your 9. So much electron volt. And this will be how much? 9 1s are 9. This is now 3. Then this is now 327. And this is now 6. So much electron volt. Similarly, third binding energy, third ionization energy. Now this is 1 to 2.4 upon. This is equal to how much? 4. So this is now your 16 electron volt. And this is now your 7 point लगभग इतना इलेक्ट्रॉन वोल्ट इसकी एनर्जी आएगी. So as we go higher and higher, this ionization energy decreases because the energy of the state decreases. So that the energy of this ionization energy also goes on decreasing. So now what we have, that if suppose the electron is in third energy state or the second energy state, etc., then we can find if we have for hydrogen atom, this is now n equal to 1. This is now n equal to 2. So here there are the 2 electrons. This is not 2 electrons. This is now 1 electron. So this is 1s2. 1s2. This is now your 2s1. Second energy state now, then this is now your third energy state. N equal to 3. Then this is now your fourth energy state. N equal to 4. And so on. That we will go up to infinity. So this electron is to be excited to this one. This electron is to be excited. No. Not like this. This electron has to be gone this up to this energy state here. This is now your zero energy. Zero energy. And similarly, if the electron, suppose this is in this third energy state, then it has to go here. So this is now zero energy state, and here we are having the energies to be so much of the lithium atom, that is equal to this is n equal to 2. So this is now your 30.6 electron volt, and that here this lies your 13 points, your how much, 6 electron volt. So just you find that this is now 4, 6 is 24, and here 13.69, 9, this is now 1, this is now 3, 5, 9, 6, 54, so much, and this will continue. So here this will be now 0, here this will be now 0. So this energy goes on like this one. So if the electron lies in the second energy state for the lithium atom, then the bonding, then ionization energy will be so much. If this electron is found in the third energy state, then this will go like this one. Then this so much is the second. If we have this n equal to 4, the third energy state, n equal to 4 to be here, so this will be your 7.6. 7.65 electron volt, like this one. So this is for lithium atom. For lithium 37 atom. If we have suppose the hydrogen atom, this is n equal to 1, this is n equal to 2, this is n equal to 3, this is n equal to 4. So now what? Similarly, if we go like this, then this is now infinity. The electron is lying here in the hydrogen atom. Electron lying in this, so this goes to infinity. Then this is now first binding energy like this goes to like this one. If suppose this electron is found in this state, then it has to go like this one. And if this is found in this state, then it has to go like this one. So if the electron is in the first energy state, then so much will be the ionization energy. If the electron is in second energy state, then so much will be the ionization energy. If the electron is in third energy state, then so much will be the ionization energy. So depending upon the situation of the electron in the energy state, that will be the ionization energy of the atom. So this is what the ionization energy of the hydrogen-like atoms and ions. Thank you very much.